The NVIDIA GeForce RTX 3080 was a monumental leap in graphics performance upon its release, but its power came with a significant thermal challenge. While most users focus on the GPU core temperature, a more critical metric often goes unnoticed. Alcanzan the GDDR6 X memory junction temperature. This specific sensor measures the hottest point on the memory modules themselves. These chips can, and often do, run substantially hotter than the GPU core, creating a bottleneck that can degrade performance and potentially shorten the lifespan of your expensive graphics card. High memory temperatures are not just a number on a screen, they are a direct threat to stability and longevity. Understanding why this temperature matters is the first step toward a solution. GDDR6X memory has a maximum operating temperature, often cited by Micron, the manufacturer, as being around 105 degrees Celsius to 110 degrees Celsius for the junction. Fortunately, several free and widely available software utilities can report this specific temperature. Applications like HWInfo64 are preferred tool for its detailed sensor list. GPU-Z or even the monitoring overlay in MSI Afterburner can display the GPU memory junction temperature. Before you make any changes, your first task is to establish a baseline. Run a demanding application, a graphically intensive game at high settings, or a GPU stress test like Furmark for at least 30 minutes and record the peak memory junction temperature. This number is your starting point, the figure we aim to reduce. Before you even think about picking up a screwdriver, your first line of attack should be software-based adjustments. These are the safest, cheapest, often surprisingly effective. The most immediate tool at your disposal is the GPU's own fan control. Most graphics cards ship with a conservative default fan curve designed to prioritize low noise levels over aggressive cooling. By taking manual control, you can force the fans to work harder when temperatures start to climb. Use MSI Afterburner or EVGA Precision X1, set a custom fan curve that ramps up fan speed more steeply in relation to temperature. For example, set the fans to hit 70% speed once the GPU core reaches 65 degrees Celsius, and set 85 to 90% speed if it hits 75 degrees Celsius. While this will increase the audible noise from your system, the improved airflow directly across the heatsink fins can have a significant impact. That benefits the GPU core and the memory modules cooled by the same assembly. After setting a more aggressive curve, save the profile and ensure it applies at system startup. Then, run the same stress test you used to establish your baseline. You may find this simple adjustment alone drops your memory junction temperature by several degrees, putting you in a much safer thermal territory. With initial software tweaks complete, the next logical step is to look at the physical environment inside your PC case. The most effective cooling solution in the world will fail if it is starved for fresh, cool air. Case airflow is a fundamental principle of PC building that directly impacts every single component, especially a heat-generating monster like the RTX 3080. Start by inspecting your case's fan configuration. An optimal setup typically involves intake fans at the front, intake fans at the bottom, and exhaust fans at the rear, and exhaust fans at the top, pushing hot air out. This creates a clear and consistent airflow path over your components. Ensure your fans are oriented correctly. There are usually small arrows on the fan housing indicating the direction of airflow and blade spin. Also, check for obstructions. Poor cable management can create walls of wires that block airflow, creating hotspots and preventing cool air from reaching the GPU. Take some time to route cables behind the motherboard tray or tie them down neatly to clear the path between your intake fans and your graphics card. If your case has empty fan mounts, particularly in the front intake position, adding 1 or 2 quality static pressure fans can dramatically improve the amount of cool air being supplied to the GPU, directly benefiting memory temperatures. Over time, even the best ventilated case will accumulate dust, which is the mortal enemy of effective cooling. Dust acts as an insulator, blanketing heatsink fins, clogging fan blades, and obstructing mesh filters. This layer of insulation prevents heat from dissipating efficiently, causing temperatures to slowly creep up over months of use. A thorough cleaning is a free and highly effective maintenance step. Power down your system, unplug it, and take it to a well-ventilated area. Using a can of compressed air and a soft brush, carefully clean all the dust from your case's intake filters, fan blades, and most importantly, the heatsink fins of the RTX 3080 itself. Pay close attention to the GPU. Hold the fans in place with a finger to prevent them from overspinning as you blow compressed air through the heatsink from all angles. You may be shocked at the amount of dust that gets dislodged. If software tweaks and cleaning haven't fully solved your thermal issues, the next step is to control the source of the heat: power. The RTX 3080 is a power-hungry card, and more power directly translates to more heat. One simple fix is adjusting the power limit. Open MSI Afterburner. Reduce the card's maximum power draw. Slide power limit to 90%. Slide power limit to 85% if needed. That reduces heat from the GPU core. And it reduces heat from the memory. The trade-off is a slight hit to max performance, often just a few percent drop in frame rates. But thermal and acoustic gains can be big. Many gamers trade 3-5 FPS for a 10 degrees Celsius drop in memory temperature and a noticeably quieter system. It's a simple, safe adjustment. Test in 5% steps to find your balance. A more advanced option is undervolting. Undervolting keeps clocks similar while cutting voltage. Power falls with voltage squared. So, small voltage drops matter. Use the voltage frequency curve editor in MSI Afterburner, Ctrl+F. Find the lowest stable voltage for your target clock. Example, 1900 MHz at 0.875 volts. Default behavior might push to around 1.05 volts or higher. Set a flatter curve to make the card more efficient. This takes patience and stability testing. Make sure the combo doesn't crash games or benchmarks. A stable undervolt can shave 5 to 15 degrees Celsius off memory temps with virtually no performance loss, and sometimes even better performance from less throttling. This is arguably the single most effective software fix for heat issues. Finally, consider the ambient temperature of the room your PC is in. Improve room ventilation. Use air conditioning. Don't place the PC in a cramped cabinet. Avoid placing it next to a radiator. Every degree you lower the ambient temperature is a degree your components don't have to fight against. If you have exhausted all software, airflow, and cleaning options and your memory junction temperatures are still stubbornly high, for example, consistently over 105 degrees Celsius, it may be time to consider a hardware modification, replacing the thermal pads. On many launch-era RTX 3080 models, the stock thermal pads between the GDDR6X memory modules and the heatsink were poor quality or incorrect thickness. These pads can be overly squishy, oily, not conductive enough, failing to transfer heat away from the memory chips. Replacing them with high-quality aftermarket pads can produce dramatic results, often the definitive fix. This procedure is not for the faint of heart, and will almost certainly void your card's warranty. It requires full disassembly, including removing the heatsink assembly. Be meticulous, be patient, work in a clean, static-free environment. Before you begin, research the exact thermal pad thickness for your RTX 3080 model. Pads too thick can prevent proper GPU die contact with the cold plate, causing dangerously high core temps. Pads too thin will create a gap, failing to cool the memory. Use online communities and tutorials for this info. Get correct high-quality pads. Gelid, Thermalright, critical pads. Then carefully unscrew the backplate and heatsink. Disconnect the fan header. Disconnect the LED header. Separate the main PCB from the cooling assembly. Gently peel off the old, often oily, stock pads from the memory chips, then from the heatsink. Clean residue from the memory modules and from heatsink contact points with a cotton swab and 99% isopropyl alcohol. Apply the new, precisely cut thermal pads to the memory chips. Clean and reapply high-quality thermal paste to the GPU die. Reassemble the card carefully. Ensure screws are tightened evenly, and all headers reconnected. Power on the system and run your stress test. Users often report immediate, drastic improvements, with memory junction temps dropping by as much as 20 to 30 degrees Celsius. Despite the risk, proper thermal pad replacement often solves hot GDDR6X on the RTX 3080. Making changes to your system is only half the battle. The other half is verifying those changes had the desired effect. Rigorous and consistent monitoring is the only way to objectively measure success. After each adjustment, whether it was cleaning the case, setting a new fan curve, replacing the thermal pads, repeat the same baseline test you ran at the start for at least 30 minutes. Keep a log of your results. Record peak GPU core temperature, peak memory junction temperature, average GPU clock speed, ambient room temperature. This data-driven approach removes guesswork. Seeing memory junction temps drop from 108 degrees Celsius to 96 degrees after adjusting fan curve and power limit is concrete proof. If a change gives no improvement, or worse, higher temps, revert and try something else. Test for stability, especially after undervolting or big power limit changes. 10-minute tests can be misleading. Crashes may happen after an hour of heavy gaming. Long-term testing is key. After you find good settings, use the PC normally for several days. A successful fix is thermally efficient and stable for daily use. Your monitoring data will create a clear before and after picture. Tackling high memory temperatures on an RTX 3080 is a manageable process that can yield significant rewards in performance, stability, hardware longevity. The key is a methodical approach, starting with the least invasive fixes and progressing only as needed. Improved airflow, thorough cleaning, intelligent software tuning, fan curves and undervolting. These steps will usually be enough to bring GDDR6X temperatures down from throttling to a safe, efficient range. Replacing the thermal pads is the definitive solution for poor stock cooling interfaces. It offers the most dramatic temperature reductions, but it carries the most risk, including voiding your warranty and potentially damaging the card if done incorrectly. Only attempt this step if you're confident and have researched your specific card model. The goal is safety. Move from dangerous or throttling temps to a safe operating range, not to chase absolute lowest numbers. To summarize, here is the final checklist. 1. Establish baseline with HWinfo 64 and a 30-minute stress test. 2. Update NVIDIA driver and check your card maker for vBIOS updates. 3. Clean filters, fans, and especially the GPU heatsink. 4. Optimize case airflow and tidy cables. 5. Set an aggressive fan curve and test. 6. Apply a 10 to 15% power limit and test. 7. Attempt an undervolt and stress test extensively. 8. If still above 100 degrees Celsius, research and replace thermal pads and paste, highest risk. 9. Final verification. Repeat the 30-minute test and enjoy your cooler, quieter GPU. If this helped, smash like, subscribe, and ring the bell for more RTX fixes and PC cooling deep dives. Drop your temps in the comments. Let's optimize together.